Hello everyone, my name is Shivam Kumar Singh. This presentation is based on my DA623 project titled Cross-Modality Retrieval, Performance, Embedding Visualization and Voice Analysis using Clip. Through this talk, I will explain how model like Clip work under the hood to enable text-based image retrieval, how we can evaluate their accuracy, and why it is important to check for social biases in this system. We often struggle to find some important image at the right time, like ID card at security check or credit card details while online shopping. At that time, it is very frustrating to look for that image among the tons of images available in our phone gallery. Thankfully, no our phone gallery app or Google Photos have features to search for image with some text prompt. No need to scroll manually. This led me to explore the working of such functionality. Now let's discuss what is CLIP. CLIP, developed by OpenAI in 2021, stands for Contrastive Language Image Pre-training. It is trained to understand both image and text and embed them into a shared vector space where semantically similar items are close together. What is powerful in that CLIP work in a zero shot setting. It doesn't need for it doesn't need retraining for new tasks. For example, if we say a photo of pizza, Clip can instantly rank all the images in the dataset to find the best match, even without seeing that specific image text before. The objective of this project are multi-step. First, I implemented text-to-image retrieval using Clip. Second, I visualized the learn embeddings to see how Clip internally organize image and prompts. Third, I evaluated performance using accuracy metrics. And lastly, I conducted a fairness evaluation, specifically looking at the gender bias across occupational roles using a balanced dataset. Here is a simple explanation of Clip's architecture. There are two encoders, one for image and one for text. Both inputs get mapped to a 512 dimensional vector. Clip uses cosine similarity to compare image and text vectors. During training, it learns how to pull matching image text pair together and push mismatched ones apart using a contrastive loss. This structure makes Clip generalizable and powerful for retrieval. To test retrieval, I started by creating a dataset of 50 common objects category, such as tree, mountain, dog, robot, and so on. For each category, I downloaded 10 high-quality images using the Unsplash API, resulting in a dataset of 500 total images. Then for each object, I used prompt like a photo of mountain or a photo of car to test if Clip could retrieve the most relevant image or not. Now we will see some of the text-to-image retrieval example. This is the first example where query is watch, and these are the three top search results. And the second query is train. These are the top three search results for the train. This one is when the search query is specific. And this one is for the search query tagger. So in all these cases, Clip was able to return very relevant results. I used top 1 and top 5 ranking to analyze whether the correct category appeared in top 1 or top 5 result. It has 0.932 accuracy for the top 1 accuracy. Even more impressively, it had 100% top 5 accuracy, which means that correct level was always in the top 5 ranked image. This gives a strong evidence that Clip is highly capable in zero-shot retrieval tasks, even without any task-specific fine-tuning. This TSNE embedding visualization helps us understand how Clip is organizing different classes internally. We could see distinct cluster forming for each category. We saw that similar objects are being grouped together in the embedding space. This provides an interpretable view of what clip has actually learned. We can see in the left there are four classes: train, bus, car and bicycle, represented by pink, red, brown and greyish color. These four belongs to automobile, so these four classes are clubbed together in left side, while the right side contains subclasses belonging to animals. Like for the lion and tiger, we can see blue and lighter green shade. Uh, Even these two animals are similar in looking. And second one, we can see dog and cat. These are similar in looking, so they are more closer even in animals subspace. uh, Dog and cat represented by green and orange respectively, and similar we can observe for purple and blue, which is to represent cow and sheep. So we can see more similar classes are clubbed together while different classes are far apart. Now let's move into the bias evaluation. I created a second dataset focused on occupation. I selected 10 jobs like doctor, nurse, mechanic, teacher, etc. and downloaded 20 images per job, evenly split between male and female. This resulted in 200 images total. This setup allowed me to evaluate how clip responds to neutral prompt like a photo of doctor. Does it prefer male over female images? Here is the evaluation approach. For each occupation, I used gender neutral prompt like a photo of nurse. Then I retrieved top 10 images using clip and checked whether each image was male or female. The idea was to analyze whether clip is implicitly based in favor of one gender for certain jobs. These slides show the actual retrieval result. Particularly this slide shows a result for a prompt a photo of doctor. We can see the clip returns 7 male images and 3 female images. Now for the query of photo of nurse, we can see clip always return a female image in the top 10 results. This shows very high biasness towards female gender in the occupation of nurse. And this is the result for search query a photo of mechanic. Clip returns 8 male image and 2 female image. From these three examples, we can understand that clip has learned biasness in gender for the occupational search. Like for doctor and mechanics, uh, model is biased towards male gender, and for the occupational like nurse, it is very highly biased towards female gender. I took it a step further and ran another TSN plot for three occupations: doctor, nurse, and mechanic. This time I colored points based on occupations and saved them based on gender. Interestingly, we could see that even within the same occupation, male and female representation formed a separate cluster, suggesting that the clip encodes gender-specific pattern in its embedding. If we look more closely, we can observe that female representation is slightly shifted towards right bottom corner. And even if we look more closely among the cluster of doctor and nurse, we can see that this cluster is more formed based on gender, not on occupation. We can see like male doctor and male nurse are more closer as compared to male doctor and male nurse. Similarly for nurse category also. This project helped me understand how powerful and general clip is when it comes to retrieval. But it also showed that even very strong models are not immune to bias. It reminded me that accuracy and fairness must go hand in hand. We can't just evaluate one and ignore the other. Embedding visualization were specifically helpful in revealing what the model has learned under the hood. Thank you for your attention.